All right, we're gonna go over the reviews worksheet for applications of derivatives. Okay, I need to share screen, start broadcast. Okay, now we need to go to, we're sharing screen. Notability, but the thing is blocked by that thing. That's wonderful. Oh, right here, notability. And I need a new sheet. There you go. And I want blue. All right, number one. Y equal x to the fourth minus 6x squared minus 8x plus 13. Graph showing all maximum, minimum, and inflection points. All right, so we need to compute the first derivative, 4x cubed minus 12x minus 8. Factor out the 4, x cubed minus 3x minus 2. And we need to do synthetic division to factor that. Don't forget to put the 0. And let's see, factors of 2 over, anyway, this is AB. Either 1 or 2 is going to work. 1 doesn't work, so it has to be 2. So 1, 2, 2, 4, 1, 2, 0. So that means we can factor it as x minus the number in the box. And then we look at the coefficient, depressed coefficients, x squared plus 2x plus 1. And that is a perfect square, x plus 1 squared. So when we make our number line, we got -1 and 2 plus, minus, minus. So it's decreasing, decreasing, increasing. So that means we're going to have an absolute maximum at x equal 2. Right? Because you can clearly see that's the lowest point on the whole graph. Okay, and then we need to find points of inflection. So we need the second derivative. Let's try to do it over here. So I think looking at this one here would be the best to compute the second derivative. 12x squared minus 12. Oh, look how beautiful that is. That's because I made the problem. And that's 12 times x plus 1 times x minus 1. So when you make your number line, -1 and 1, it's going to be plus, minus, plus. So that means it's concave up, concave down, concave up. So there's 2 points of inflection. So let's put them all in. Absolute minimum point at 2 comma, and then to figure out the y coordinate, you got to plug it back into the original equation. Oh, that could be a chore. So let's see. If you plug in 2, I'm going to do some work up here. You're going to get 16 minus 24 minus 16 plus 13. The 16s cancel out, and you get -11, absolute minimum. And then you also have 2 points of inflection, -1 something and 1 something. And we need to plug it back into the original. So if I plug in -1, you get 1 minus 6 plus 8 plus 13. So that would be 22 minus 6, which is 16. And if you plug in 1, you get 1 minus 6 minus 8 plus 13, which is 14 minus 14. That's 0. Now we need to graph. Now, I'm not sure if I'm going to make you graph. Yeah, you are, but I don't know if I'm going to make you graph on this problem. So absolute minimum is 2, -11. So looking at the scaling here, I think I'm just going to make 1, 2, 3, 4, 1, 2, 3, 4. I'm going to make my y-axis, each hash mark is 4 units. And on the x-axis will be 1. So 2, -11 would be about here. -116 would be up here. And 1, 0 would be here. Another point we could plot would be the y-intercept, which is 13. So if that's 16, 13 would be about there. Okay, so let's see now. Let's do this in red to make it a little bit different. So if we follow our number lines, the function is going to be decreasing all the way down to this absolute minimum point, then it's going to go up. And now we look at the concavity. So from negative infinity to -1, it's concave up. So we need something to look like this. And then from -1 to 1, it's concave down. So it's like, ooh, concave down. And then the rest of the way, it's going to be concave up. But then remember, that's an absolute minimum. So we're talking about a graph that looks like that. See, and that's the purpose of learning all these things. We can draw kind of pretty accurate graphs now. Okay, so the key is you got to be able to make number lines for the first and the second derivative, no matter what function it is. Number two, find all points of inflection. So we need to find when the second derivative changes sign. Okay, so this one, we need to compute the first derivative first. So using the quotient rule, low d high minus high d low all over denominator squared we go. Okay, now, the hard part for a lot of you is factoring. If you multiply it out and refactor it, that's probably going to have issues. But look, there's a 2x here and a 2x there. Why not factor it out? Because the whole purpose of this thing is to factor it. If you factor out a 2x, what's going to be left? You're going to have x squared plus 3 minus x squared minus 3. And a lot of you have issues because you guys don't put parentheses. Okay, so inside the parentheses, you get, I'm just going to do it here so we don't have to make another line. X squared plus 3. Distribute the minus sign, and you notice that the x squareds cancel out. So all you have left is 6, right? So 6 times the 2x in the front is 12x over x squared plus 3 squared. Okay, so that's the first step. Now we need second derivative. So again, we got to use the quotient rule. Low d high, which is 12, minus high d low, which is 2 box to the first times the derivative of box, all over denominator squared we go. Now we need to simplify the numerator. Well, look, I see an x squared plus 3 here and an x squared plus 3 there. You can factor that out instead of multiplying it all out. And then I see a 12 here and a 12 there, so you can factor out a 12. Okay, so if I factor that out, what's left? X squared plus 3 minus 2 times 2x, which is 4x. Let me see if I did that correctly. X squared plus 3 minus, no, 4x squared. See, there's an x over there hiding. All over denominator squared we go. Now, in the box right here, you have 3 minus 3x squared. And then you can factor out the 3 and get 1 minus x squared. And then that's the same thing as 1 plus x times 1 minus x. So putting it all together, this x squared plus 3 will cancel into one of those. And then you got a 12, but then you need to multiply it by this. So it's going to be 36, 1 plus x, 1 minus x, all over x squared plus 3 cubed. And for most of you, that's the hardest part of the whole problem, getting it down to that. So now we make our number line. Don't forget to label it. What makes the top 0? -1 and 1. What makes the bottom 0? Nothing. In fact, the bottom is always going to be positive. So if you plug in a number bigger than 1, you're going to get like negative on the top and positive on the bottom. So it's going to be minus, plus, minus. So it's concave down here, concave up, concave down. So you have 2 points of inflection at -1 and 1 because y double prime changes sign. And it just says find all the points of inflection. So points of inflection would be -1 something and 1 something. And then you have to plug it back into the original function. So let's do that. So if you plug in -1, you get 1 minus 3 over 1 plus 3 is -2/4. That's -1/2. And then if you plug in 1, you're going to get the same thing because this is an even function. It's symmetric about the y-axis, right? Because if you plug in -x for x, you get the same thing. Or if you don't believe me, just plug in 1 and you get the same numbers. See, now notice that it didn't say justify your answer, so you don't have to write, oh, these are points of inflection because y double prime changes sign. So that's why you got to read the directions. Number 3, okay, this is definitely on the test. It looks very similar to this. You just got to do it. No, use the eraser. Where's the eraser? Okay, y equals sine 2x plus 2 sine x from 0 to 2 pi. So you got a closed interval here. So remember, when you're finding absolute maximum and minimum points, you have to include the endpoints. And we need to make the candidates test. So what is going to go on the candidates test? Critical points plus the endpoints. So to find the critical points, we need to compute the derivative. The derivative of sine box is cosine box times the derivative of box plus 2 times the derivative of sine x is cosine x. Okay, now somehow we need to make a number line. We don't even have to make a number line, but we got to factor it. So take out a 2, and then you got cosine 2x plus cosine x. And again, you're going to have to use double angle identity. Cosine 2x is 2 cosine squared x minus 1. How come I chose to use that one? That's because this is cosine. If it were sine, then I would use the other one. And then I would use 1 minus 2 sine squared x. This is why you need to know your trig identities. Now let's put this in descending order. Then it should be factorable. Now, of course, if it's not factorable, you probably did something wrong. Yeah. Okay, so when will the derivative be equal to 0? Well, for this one, when cosine x equals 1/2, and then for that one, when cosine x equals -1. So when is cosine equal to 1/2? Pi over 3, 5 pi over 3. When is cosine x equal to -1? Well, that would be pi. So now we can make our candidates test. You have to do this. Some of you are still not doing it. So you put your endpoints, 0 and 2 pi there, and then you put all your critical points, and put them in order. You don't have to, but it makes it easier. Pi over 3, pi, 5 pi over 3. Now what you need to do is you need to plug each of these numbers into the original function. This could be a chore. You're going to get -1 for each one wrong, yeah? So if you get all the y coordinates wrong, there's -5 already. And that's the way we do it on the AP exam until all your points are chewed up. Okay, so if you plug in 0, let's do y of 0. What is that? 0 plus 0. Yeah, I like that one. And then, of course, if you plug in 0 and get 0, if you plug in 2 pi, you should also get 0, right? Because that's how trig functions work. Now let's plug in pi over 3. If you plug in pi over 3, you get sine of 2 pi over 3, which is √3 over 2, plus 2 times sine of pi over 3, which is √3 over 2. So if you make a least common denominator of 2, you're going to get √3 plus 2 √3. So that would be 3 √3 over 2. Okay, let's plug in pi now. So if you plug in pi, sine of 2 pi is 0, and sine of pi is also 0. Hey, you get 0 again. How you like that? Now we plug in 5 pi over 3. So y of 5 pi over 3 equals, okay, so sine of 10 pi over 3. We have to reduce that down. So here, where can I write that? Sine of 10 pi over 3. So you can subtract 2 pi from that, which is 6 pi over 3. So you can reduce it down to sine of 4 pi over 3, which is negative root 3 over 2, plus 2 times sine of 5 pi over 3, which is negative root 3 over 2. And if you make a least common denominator of 2, you're going to get negative root 3 minus 2 root 3, which is negative 3 root 3 over 2. Now, notice that it says find the absolute maximum and minimum points. So you actually have to give coordinates. So what's the biggest number on the chart? 3 root 3 over 2. So your maximum point, so absolute maximum point would be pi over 3, 3 root 3 over 2. The absolute minimum point would be what? What's the smallest number on the chart? Negative 3 root 3 over 2. So that would be your absolute minimum point, which is 5 pi over 3, negative 3 root 3 over 2. And if the question was find the absolute and absolute maximum and minimum values, then you just give the y coordinates. But like I said, if you don't know, give both. All right, number 4. Write the equation of the tangent line for f of x. Hey, this looks like an actual EP exam problem. I remember this like 10 to 20 years ago. That we have, probably that's why I put it on the worksheet. So write the equation of the tangent line when x is 0. So when x is 0, to figure out the y coordinate, you plug it in. Tangent of 0 is 0, so you get 1 to the 3 halves, which is 1. Now we need to find the slope, which means we need to compute the derivative. So box to the 3 halves, you get 3 halves box to the 1 half times the derivative of the box, which would be 0 plus the derivative of tangent box is secant squared box times the derivative of that box, which is that right there. And then the 2's cancel out, which is good. So to compute the slope at 0, you have to actually plug in 0 now. So you got 3. Tangent of 0 is 0, so 1 to the 1 half is 1. Secant of 0 is 1, so you get 3. That's the slope. So here's the point, here's the slope. Just do point slope form. Y minus 1 equal 3 times x minus 0. Move the 1 on that side, so y equal 1 plus 3x. Okay. Oh, okay. Now, use your result to estimate f of 0.2. So instead of plugging 0.2 into the original function, which would be quite ugly, we're going to plug in 0.2 into the line equation. So you're going to get 1 plus 3 times 0.2, which is 1 plus 0.6, which is 1.6. There you go. That's the answer for the first part. Is this an under or an overestimate? Well, you need to know the concavity at x equals 0. And again, don't memorize these things. Just look, draw a picture. If the graph is concave down, then look, the tangent line, the point on the line is going to be above the point on the curve, and then you have an overestimate. But if the graph of the original function is concave up, when you make the tangent line, the point on the line will be below the actual point on the curve, and then you have an underestimate. Okay, so let's rewrite this problem. Here's the first derivative. The first derivative is 3 times 1 plus tangent 2x to the half times secant squared 2x, which is like secant 2x quantity squared. Now we need to compute the second derivative in order to figure out concavity. So this 3 can be tossed on the side. So now we have a product, so you use the product rule. So derivative of the first, 1/2 box to the negative half times the derivative of box, which is 0 plus secant squared 2x times 2. Leave the second one alone, which is secant 2x squared, plus, then you leave the first one alone, 1 plus tangent 2x to the half, times the derivative of the second, which would be 2 box to the first, times the derivative of the box. The derivative of secant box would be secant box, tangent box, times the derivative of box, which is 2. Now we have to plug in 0, which shouldn't be difficult. Okay, so you're going to get 1/2. And again, tangent of 0 is 0, so that's just 1. Secant of 0 is 1 times 2. Secant of 0 is 1, so you get 1 squared, which is 1, plus 1 to the half, which is 1, times 2. Secant of 0 is 1 times 1. Tangent of 0 is 0, which just wipes out everything there. Wow, that's wiped out. So you got 1/2 times 2, which is 1 times 3. So you get 3, which is positive. If the second derivative is positive, that means the function is concave up, which means the point on the line is below the curve, which means we have an underestimate. Does it say, oh, it doesn't even ask you why. Well, on the test, I might ask you why. What if I ask you to explain? It's an underestimate because we're just practicing, because it doesn't say you have to do this, but we're just practicing. Because F, you have to mention the thing by name now. F is concave up at x equals 0, since F double prime of 0 is positive. Now it says write an expression that gives the percent error now. How do you find the percent error? So from science, so experimental, which is this, right? So 1.6 minus the actual. So to get the actual, you have to plug in 0.2 into the original function. This was the original function. So I'm going to rewrite it here so I don't have to keep scrolling. F of x is equal to 1 plus tangent 2x to the 3/2. So if you plug in 0.2 into this, you're going to get 1 plus tangent of 0.4 to the 3/2 power, all over the actual 1 plus tangent of 0.4 to the 3/2 power times 100. This is your percent error. And since you don't have a calculator on the test, you're just going to leave your answer like that. Number 5, find the value or values of C that satisfy the mean value theorem for this function. And notice that it's a polynomial, which is always continuous and smooth. So that means, yes, is going to be at least one answer on the interval from 1 to 3. So remember, the mean value theorem says that if a function is differentiable on an interval, then there's at least one value of C such that f prime of C is equal to f of B minus f of A all over B minus A. So first of all, we need to compute the derivative. So that would be 3x squared minus 10x. So f prime of C means plug in C. So 3c squared minus 10c. Now, you don't really have to plug in C. You can just use the x's, right? As long as you know what's going on. And then now we need to compute f of 3 minus f of 1 all over 3 minus 1. So if you plug in 3 into the original function, you're going to have to do some work here. You get 27 minus 45. That would be negative 18 minus f of 1. That would be 1 minus 5, which would be negative 4. All over 3 minus 1 is 2. So that's negative 18 plus 4 over 2, which is negative 14 over 2, which is negative 7. So that equals negative 7. See, so this is f prime of c, and this is f of 3 minus f of 1 over 3 minus 1. We need to solve this equation. So this is a quadratic, so you make one side 0. And if I made this problem, probably it's going to factor. So 7, 1, minus, minus. Yep, that works. So C equals 7/3 or 1. And you might say, oh, yeah, I get two answers. However, this is a trick problem, which they often put on the multiple choice. Remember, the value of C that you find has to be between A and B. This is important. So that's why you have to cross out that 1, because 1 is not between 1 and 3. So a little bit tricky, but if you did that, I'd probably take off only 1 or 2 points. Let's make it 2. Okay, 6, f of 3 equals 2. Hey, we had a problem like this on the practice test. This is the practice test. I mean, you had it on the worksheet. F prime of 3 is equal to 4. F double prime of 3 is equal to negative 1. Write the linearization. Now, that's a term we used in our old book. Linearization simply means the equation of the tangent line, okay? So write the equation of the tangent line at x equals 3, okay? So we need a point that comes from this, and then we need the slope, and when x is 3, that comes from this, right? Because the derivative tells you the slope. And then you do point slope form. Y minus 2 equal 4 times x minus 3. Move the 2 on the other side. There. Now, use your result to estimate f of 3.1. So instead of plugging in 3.1 into the original function, which we don't even know, we're going to plug in 3.1 into the line equation that we just write. So we got 2 plus 4 times 3.1 minus 3, which is 2 plus 4 times 0.1, which is 2 plus 0.4, which is 2.4. There you go. That's a good estimate of whatever the function was. Now, is this an under or an overestimate? Now you need to justify your answer. So we need to know the concavity of the graph when x equals 3. So we look at the second derivative. Everything's given you. Like the other problem, we have to figure out everything. Everything's given here. So negative 1 is negative, which means f is concave down, which means when you have your point on the line, it's going to be above the actual point. So this is an overestimate because f is concave down since f double prime of 3 is negative. Bam. Full credit. Okay, number 7. Okay, I'm giving you the graph of f prime and you have to sketch. Okay, this is definitely on the test. 1, 2, 3. And it all comes down to making number lines. That's all it comes down to. So let's see if I can draw this now. Let's see. Hey, it came out to a straight line. I don't want that. And then, okay, this is the graph of f prime now. Y equal f prime of x. Very important. Okay, so in order to sketch a possible graph, you need to make number lines for the first and the second derivative. So first derivative is here. Now, it's like you graph the derivative on your calculator, you're looking at it, just simply make a number line for it. Where does this graph touch the x-axis? Well, at -2, 0, and 2. And if it's above the x-axis, you put plus. Then it goes below, then it goes above, and then it stays above. Now, what does this all mean? That means the original function f is increasing, decreasing, increasing, and increasing. So that means there's going to be a local maximum at -2, and there's going to be a local minimum at 0. And if it were to, like, if you had to justify your answer, there's a local max at x equal -2 because f prime changes from plus to minus. There's a local minimum at x equals 0 because f prime changes from minus to plus. And there's neither at x equal 2 because f prime doesn't change sign. However, there's no justification on this problem. Now we need to make a number line for the second derivative, which is the derivative of this graph or the slope of this graph. So the first thing you look for is, where is the slope 0? Like those 3 points. That's what you put on your number line. So the slope is 0 at -1, 1. I'm trying to match it up with the upper number line, and 2. And then what kind of signs do you put? You look at the slope. From -3 to -1, if the graph is going downhill, it has a negative slope. So you just, downhill, it has a negative slope. Uphill, positive slope. Downhill, negative slope. Uphill, positive slope. You're making a number line for the slope of that graph. And then, of course, what does that mean? It's concave down here, concave up, concave down, concave up. So all 3 of these numbers, -1, 1, and 2, these are all points of inflection because f double prime changes sign. Okay, now we got to draw a graph. So let's pick a different color. What color haven't we used? Let's do pink. No, I don't want. Let's do green. So just follow your number lines. Now it doesn't say where to start the graph, so you can start it wherever you want. I'm going to start it right here. I don't like that green. Let's do this other green. Yeah, I like that one there. Okay, so start it wherever you want. And then now follow your number lines from -3 to -2. Look at your number lines. The graph has to be increasing and concave down. So something like that. Then from -2 to -1, it's decreasing and concave down. So something like that. And then from -1 to 0, it's decreasing and concave up. Something like that. Then from 0 to 1, it's increasing and concave up. And then from 1 to 2, increasing and concave down. So something like that. And then finally, from 2 to 3, increasing and concave up. So your graph should look something like that. So it all depends on where you started. Like, what if you wanted to start down here and you, instead of medium bulges, you like big bulges. So your graph could look something like this, this, and that. As long as it has the same characteristics. All right, number 8. This looks like the second derivative test just by looking at the problem. 2x plus y. Is the point -1, 2 a local maximum, a local minimum, or neither? Justify your answer. Now, you cannot make a number line when there's x's and y's in it. You cannot. So that's why you need to use the second derivative test. So what's the first thing you got to find out? You got to make sure the first derivative is 0. So at the point -1, 2, dy dx is equal to 2 times -1 plus 2, which is 0. Okay, so there is going to be a possible maximum or minimum there. Now, if it doesn't come out to 0, then the answer would be neither. And you can just say because the first derivative is not 0. But then what's the point otherwise, right? Now we need to look at the second derivative. So I'm just going to write y double prime. Or if you want to write y to d2y over dx squared, d squared y over dx squared, whatever. It's going to be 2 plus dy dx. Remember, when you do implicit differentiation, the derivative of x is 1 and the derivative of y is dy dx. And then we can substitute for dy dx because in the previous problem, dy dx, or it's actually given, it's 2x plus y. So at the point -1, 2, the second derivative is equal to 2 plus -2 plus 2. And that comes out to 2, which is a positive number. So if the graph is concave up and the slope is 0, look at that. There's a local minimum. So the answer is there's a local minimum because of the second derivative test. This is the name of a theorem. It doesn't even look like a D. But you also have to show all this supporting work over here. You cannot just say it's a local min because of the second derivative test. You actually have to show the first derivative is 0 and the second derivative comes out positive at the given point. Okay, number 9. This problem is on every AP exam. It's going to be on your test. Make sure you can do it. Oh, okay, now I'm going to have to redraw it. And like I told you guys in class, it's always like they give you a semicircle with some line segments. It's always the same. They just alter it a little bit. So it goes down to here, and they label some of the points, and that's probably going to come into play here. So 4, 2, 2, 4, 2, and then it goes down to 6, 0, 2. Okay, so that's 6. All right, this is the graph of F prime now. So it's asking, at what values of X does the F have a point of inflection? Explain. So again, we need to find the second, we'll make a number line for the second derivative and see where it changes sign. So the second derivative is simply the slope or the derivative of this graph. So we have to look, where is the slope 0? Well, there's only one place right there. That's the only place where the slope is 0. So put 0 on the number line. And then we have to look at sharp points. Well, I see sharp point right there, and right there. So also on the number line, you got to have -2, 2, and 4. Okay, and again, what are we looking for? The slope. So from -4 to -2, see how the graph is going uphill like that? It means the slope is positive. Then from -2 to 0, the graph is going downhill, then it has a negative slope. And then it's going uphill, positive slope. From 2 to 4, it's going uphill some more, so positive slope. And then from 4 to 6, it's going downhill, it has a negative slope. So looking at your number line, where does F double prime change sign? So there's a point of inflection at X equal -2, 0, and 4. Not at 2 because it doesn't change sign. And it says, explain. Because F double prime changes sign. That's your explanation. And then the final problem here is L'Hopital's rule. That was the last section we learned here. So A, compute the limit as X approaches 0 of 2 sine X minus sine 2X all over sine. Oh, this looks like a fun problem. I can tell just by looking at it. Now remember, you can only use L'Hopital's rule when it's 0 over 0 or infinity over infinity. So the first thing you do is you plug in the number. If you plug in 0, you're going to get 0 minus 0 over 0 minus 0, which is 0 over 0. So that means we can use L'Hopital's rule. So L'Hopital's rule says, take the derivative of the top. So that would be 2 cosine X minus cosine 2X times 2, right? Because the derivative of the box is 2. See, if you don't put that 2 there, it's all over but the crying right there. Now, take the derivative of the bottom. That would be cosine X minus, and now this is a product. You need to use the product rule. So derivative of the first, which is 1, leave the second one alone, plus leave the first one alone, and the derivative of the second is negative sine X. So that would become a minus sign. Minus X sine X. And then you might want to simplify this before you go on. So this is 2 cosine X minus 2 cosine 2X. When you distribute that minus sign, the cosines cancel out, and then it becomes positive X sine X. Now plug in 0. So you get 2 minus 2 over 0. So it's still 0 over 0, So you can use L'Hopital's rule again. So take the derivative of the top. So that would be -2 sine x. The -2 is a constant. Toss it on the side. The derivative of cosine 2x is negative sine 2x times 2. And the denominator is a product, so you got to use the product rule. Derivative of the first, which is 1, leave the second one alone, plus leave the first one alone. Derivative of sine, which is cosine. Okay, now can I plug in 0 and get something? Well, let's simplify it first. I would simplify this to -2 sine x plus 4 sine 2x. Oh, this is a fun problem, man. Okay, if you plug in 0, it's still 0 over 0. So we're going to L'Hopital it again. Hopefully this will be the last time. Take the derivative of the top. -2, I think this is it. I can kind of tell here. Plus 4 times the derivative of sine 2x is cosine 2x times 2. Now take the derivative of the bottom. Cosine x plus, now we got to use the product rule on this. So derivative of the first, which is 1, leave the second one alone. First one, the derivative of cosine is negative sine x. There you go. Now can you plug in 0 and get something? And the answer is yes. If you plug in 0, you get -2 plus 8 all over 1 plus 1 plus 0, which is 6 over 2, which is 3. I like that. I really like that problem. And then B. Now you got to remember on the AP exam, they give you information in all kinds of different ways. So the reason why I put this on is because I've seen this multiple times on the AP exam. It's not always going to be just give you functions. They want you to interpret graphs. Okay, and the graph of f of x is shown below. That means I gotta draw it here. Oh my goodness. Hey, that's the same graph we had before. That's okay, it doesn't matter. We're just gonna use it for whatever we need, right? So we got a semicircle, a line segment that goes down to 4, -1. And then it goes up to 4, 2, 2, 2, 2, and then down to 6, 0. So in the other problem, this was the graph of f prime, but now this is just the graph of f. Okay, so the first thing you do is plug in the number. What is the limit as x approach? How do you compute the limit as x approaches 5? So you plug in the number. You get f of 5. Oh, you know what? I'll tell you what. On the AP exam, we discussed this in class, but on the AP exam, you cannot write 0 over 0 on your paper because 0 over 0 is undefined. Even though all the books write it, AP exam doesn't like it. So whenever you're using L'Hopital's rule, like I told you in class, you have to work with the numerator and denominator separately. So here, I'm going to do it right here. So what you have to do is you have to find the limit of f of x minus 1. And then you got to find the limit as x approaches 5 of the denominator, which is x squared minus 3x minus 10. Okay, so this is equal to f of 5 minus 1. But what is f of 5 equal to? Well, if you look at the graph, f of 5 would be the y coordinate of that point right there, which is 1, right? So 1 minus 1 is 0. And then for this other limit, you plug in the number, you get 25 minus 15 minus 10, which is 0. See, they don't want you to write 0 over 0 because that's undefined. They want you to work with the numerator and denominator separately, which I don't like. I don't like a lot of things, but we just have to do it if we want to get points. Now, of course, if this is a multiple choice question, like I'm thinking the top one there would be a multiple choice question, then they don't care, right? You just got to pick out the right answer. So now, since it came out 0 over 0, you can use L'Hopital's rule. So you take the limit as x approaches 5 of the numerator, which is f prime of x minus 0. Why did I even put brackets there? Let's one, and then we have to take the limit as x approaches 5 of the derivative of this, which is 2x minus 3. Okay, so this one is equal to f prime of 5. Now, going back to the graph, is if this is the graph of f of x, f prime of 5 means what is the slope right at that point? So in other words, we need to compute the slope of that line. But that's easy, right? Because you're given 2 points. This is the point 4 comma 2. This is the point 6 comma 0. You can use the slope formula. So 2 minus 0 over 4 minus 6, which is 2 over negative 2, which is negative 1. Or you can just make a triangle and go, oh, rise over run, and it's going downhill, negative 1. Whatever. And then, how do you compute this limit? Well, you simply plug in the number, right? That's what you always should do first. Then you get 10 minus 3, which is 7. So then your final answer is negative 1, 7. See, because remember, that was the numerator. This is the denominator. They just want you to work with the numerator and denominator separately. All right, I did all of it, and I'm tired. So I spent my entire morning making this video for you. I hope you guys appreciate it and use it so that you guys can get higher scores. All right, that's it. I'm signing off. Good. Bye. I don't know what happened here. Why am I still on here? Do I have to press this button? End it. End it, I tell you.